Hi, boys and girls. This is Mrs. Milligan, and this video goes along with the Heat Shield Engineer video on STEM scopes. The guiding questions are found in a separate doc, and you'll just answer those questions based on the video. But what I want to show you right now is kind of a complement to that background info. I found this recent article, and it's called The NASA Engineers Struggling to Build a Better Heat Shield. So this article was from less than a year ago. So it kind of gives you an idea of how relevant this job role is and how much cutting edge technology and stuff that's happening in space. So I'm going to kind of read through and skim the articles, and I just want you to put your mind kind of in that NASA creative, competitive environment for a second. For months on end, the samples kept melting. This wasn't exactly surprising. The cork-filled fiberglass honeycomb was being subjected to a blast of heat 4 times more intense than what the space shuttle's leading edge withstood on re-entering Earth's atmosphere. It was like putting the world's hottest oven in the middle of its most powerful wind tunnel. So, boys and girls, this is what we are going to start studying, is like that kinetic energy, and also with thermal energy and like that heat, and how to make it safe for people to explore space a little bit better. So this next paragraph just talks about what materials they really need to use to create a heat shield, because they're working about an entry to Mars. So they're talking about some things that failed, some things that just didn't work. And this specific engineer is a female, and she never gave up. She kept trying, but it took like years to do. So this says, in the wake of those failures, Wang's team faced a serious time crunch. So it was 2007, and the launch was scheduled in less than 2 years. There were 2 options as she saw it. She could redesign the mission to try to reduce the heating conditions, or to come up with a new heat shield material. The first option would limit where the rover could land and the scientific instruments it could carry. The second option meant that they would have to design, develop, test, and build a new heat shield in less than 18 months. The option was risky, but it would allow the mission to do all the science it was meant to do. So this is the design process. This is what you're doing. This is what you're doing with the roller coaster. This website is technologyreview.com, and it's from a magazine called MIT Tech Review. So they chose the second option. As the humans' ambitions grew in space, our ingenuity is going to have to match them. So we want to explore the dense atmospheres like Venus or Saturn, but we need ultra robust heat shields that can handle intense pressures. So if we were going to send the Martian samples back to Earth, we need indestructible heat shields that will prevent any alien life form from contaminating our planet, or us contaminating their planet. Landing humans on other planets will require supersizing aeroshells, the entry capsules protected by heat shields, to a diameter of almost 20 meters across or more. So nothing close to that scale has ever been flown to Mars before. So the rest of the article talks about the challenges of developing these technologies, but it's saying that everything so far will just burn up in the atmosphere. So if you go into space, there's 2 reasons to slow down: to return to Earth, or to stop at another celestial body. So one way to slow down is to use the same method you use to speed up, which are rockets. But this means you're carrying more rocket fuel, which adds weight. As a practical matter, it makes sense to use the atmosphere if there is one. So surviving the resulting heat requires clever materials and cleverly shaped spacecraft. Then it goes on to talk about things that they have initially created and some goals that we have. This is like a prototype, I guess, and they named it, but it's guaranteed to enter and do extreme environments like Saturn or Neptune. So it's the unthinkable. But if you are thinking about a career in engineering, this is kind of the topic right now with NASA. So good luck, and I hope you had a little bit of a chance to explore. That's what science is about, is exploring the solar system and how things work in our world. So we will talk to you later.